A motorbike accelerates at a constant rate of 3 meters per second squared. Calculate the time taken to accelerate from 18 to 45 kilometers per hour. So for part A, we know the initial velocity, the final velocity, and the constant acceleration. So the logical equation to use here would be V equals U plus AT. T being the only unknown value here. But we do need to be careful because the initial velocity and the final velocity are given in kilometers per hour, but we're asked to calculate the time using an acceleration of meters per second squared. So we have two units here, meters and kilometers. So we better convert the velocities to meters per second before we continue. So let's look at the first velocity, 18 kilometers per hour. U equals 18 kilometers per hour. But I'd like that to be meters per second. So I can rewrite that as 18 1,000 meters in place of kilometers and 3,600 seconds in place of hours. And that gives me an answer of 5 meters per second. So 18 kilometers per hour is equivalent to 5 meters per second. Similarly for the final velocity, which is 45 kilometers per hour, I can rewrite that as 45, change the kilometers to meters, so wherever we see a kilometer symbol we just write 1,000 meters, and whenever we see the hour symbol we can change that to 3,600 seconds. So now we're working in units of meters per second, and this gives speed of 12.5 meters per second. Substituting this into the equation V equals U plus AT, we obtain 12.5 equals 5 plus 3 t, and I can rearrange that for t to get t equals 7.5 divided by 3, which equals 2.5 seconds. So it takes 2.5 seconds to accelerate from 18 to 45 kilometers per hour. Now to solve the second part, the distance in meters that's covered in this time, we need to use a different equation because we need to find the distance covered rather than the time. So this suggests using the equation S equals a half U plus V times the time. Now we worked out the time from part A and we found that it was 2.5 seconds, and we also calculated the initial velocity in meters per second, which was 5, And we converted the final velocity also to meters per second, and we found that was 12.5. So we have all the information we need. We can substitute those values in, and we'll find that the distance travelled is a half, 12.5 plus 5 times the time, which is 2.5. And you can work that out, and it turns out that it's 21.875 meters. It's meters because we converted our velocities to meters per second.